Hey guys, welcome. There are many interesting proofs of the Pythagorean Theorem, and although no one has challenged me to do this, I will at some point make 50 different proofs of the Pythagorean Theorem. And so let's get on with our first. This is about the most traditional proof of the Pythagorean Theorem. Now, what we want to show is that in a right triangle where two legs have measure A and B and the hypotenuse has measure C, that the square of A plus the square of B is equal to the square of C. That's what we want to show, right? Okay, so let's clearly state what we want to show. This. Now, this very traditional proof starts through this construction. So you have a larger square, the blue square, and a smaller square within it that touches the larger square at 4 points 1, 2, 3, and 4. Yes, you heard me say that this red quadrilateral is a square. First of all of its sides are equal, so that only makes it a rhombus, right? And so we need 4 right angles, and these angles are in fact right angles. Why, you say? Because here in this right triangle, alpha plus beta is 90. So if we look at this 180 degree line right here, like one of the sides here, right? This angle here measures 180. And so if alpha and beta sum to 90, then this angle right here and this red square has to be 90. Yeah? So this is in fact a square, the red guy here. Okay. So the way we proceed is in this fashion. Well, we know on the one hand that the area of the larger square, the big blue square, is equal to the area of this smaller red square plus 4 of the triangle's areas, right? So we know that the area of the large blue square is equal to the area of the small square, the red square, plus 4 times the area of one of the right triangles, right? Okay, cool. Alright, so let's write this down then. So this is going to be c squared plus 4 times 1/2 AB. Obviously, the c squared is for the area of this red square. And then one of the blue right triangles has area 1/2 AB, so 4 times that is that. And of course, this here simplifies to this here, yeah? But wait, there's another way to figure out the area of the big square, the big blue square. And that is, well, the big blue square has a side measuring A plus B. Whichever side we pick, it's A plus B, right? The measure. And so then its area is A plus B all squared, right? Okay. But then, regardless of how we compute the area of the big blue square, the area has to stay the same. That's to say that this has to hold, right? The one way we found the area of the big blue square has to be the same as the other way that we found the area, and therefore that means that this equation has to hold true. And of course, upon cancellation of the 2ab quantity from both sides, that is subtracting 2ab from both sides of this very last equation I displayed, we get the Pythagorean Theorem. Yeah, cool. Alright, I hope you enjoyed this. Keep watching. Take care.